Welcome everybody. We got an interesting question. Foremost, we will have to create a circle. Okay, so we got the semicircle, and inside the semicircle we have an inscribed circle. Now we are given this length. Okay, this length is given, and that is given to be as 16 units. Now this distance is given. I'm going to take this as P. This is center O. This distance is given as 24 units. We are asked to find R. R is the radii of the small circle. Okay, so with these information we will have to start this question, right? So you can go through this, you can work it out, and when we come back, let's see how to do it. Okay, so I hope you all have got that. Foremost, we are going to take a few assignments, or I would say we are going to assign variables to the structure. And in doing so, let us start off with capital R. So let capital R be the radius of the semicircle, and let small r be the radius of the circle. Okay, so when we talk about circle, we are talking about the small circle that is present there. Next, what I wish to do is, I have already taken the radius as capital R, so this entire distance is going to be capital R. Okay, now since PB is equal to 24, okay, so this entire length is given as 24 units. So if I were to take this point as some m, okay, so this means PM is going to be 24. From 24 you take away R, that is going to be giving me PM, right? So with that being obtained, what I would do now is I would like to actually connect the circumference with the center. So that can always be done, right? So from the center we actually send out a line to meet the circumference. Okay, so we get that there. Now this is clearly a 90-degree angle. This is clearly 90 degrees, and I would be taking this as some z. Okay, so consider triangle ZPM, and by Pythagoras theorem we get, so what do we get by Pythagoras theorem? So we have PZ squared plus PM squared is equal to MZ squared, right? So PZ squared is 16 squared, PM squared is 24 negative R raised to the power of 2, since you have a square there, Now MZ is actually the radius of the semicircle, right? So you can substitute r squared there, and in doing so we can actually perform the simplification and find r. So let me write the objective. The objective is to find r. That is the objective of this part. So I retain it as 16 squared. I square this, 24 squared negative 48r positive r squared is equal to r squared. These two gets cancelled. I move 48r to the other side. 16 into 16, 36, 3, 9, 6, 1, and you get 256. 24 into 24. Both are 16, 1, 8, 9, 8, 4, 6, 17 and 5, 576. So you have 256 added with 576. So we add 256 with 576. 12, 1, 13, 1, 8. So 48r is 832. So r is equal to 832 divided by 48. So 8 can divide here, right? So 8 divides here once, 8 does not divide here. 8 4s are 32, and 8 divides here 6 times, 2 divides here 3 times, 2 divides here 5 times, 2 times. So r is equal to 52 over 3. So that's not a good looking number, but we got to work with that. Okay, so next let us go back to the figure. Now if you see this figure, you have the point of tangency between the two circles. So by tangent to the circle theorem, if I were to draw a line through the point of tangency, then that line would pass through the centers of the circle. So that is the understanding there. So I'm going to correct it. So this is the center. So the line passes through the center. Now let me take this point as some y. Okay. Now OY is r, which is the radii of the small circle. So I can have that. Now what would be OM? Now capital R is 52 divided by 3, is it not? That's the value we got there. So having obtained that value, if you want to get this OM, that is going to be from MY, I subtract OY. Now what is MY? MY is the radius capital R, and OY is small r. Capital R is found to be as 52 over 3 negative r, so this is OM. So we have got that value. Now why do we need this value? Because we are creating a right angle triangle, so we need this. So having got that, let me now drop a perpendicular from O to the point of tangency. If I were to do that, because by the tangent to the circle theorem, a line drawn from the center to the point of tangency to the circle will always be 90 degrees. So this is going to be 90 degrees. Okay. Now having got that, what I would like to do next is to drop a perpendicular from this point to M. So let me do that. So if I were to do that, I would get a right angle triangle like that. So let me take this point as some Q. So clearly OQ, now we will have to get the value of OQ. Before we could get the value of OQ, let me calculate the value of PM. Now as I mentioned to you, PM, we have evaluated or got the value for PM as 24 negative R. So this from 24 you take away 52 over 3. So 4 3s are 12, 72 negative 52 divided by 3. That is going to give me 20 over 3. So this value is 20 divided by 3. Now if this value is 20 divided by 3, then we would be able to get this value. Okay, this value can be got because this entire length is r units, right? This entire length is actually r units. So from r, OQ is going to be, I need OQ. So how do I get OQ? OQ is got from the small r radius, you take away 20 over 3. So that is my OQ. Okay, so I've already mentioned to you that this is a right angle triangle and we know OM, right? OM is present here, but we need QM. So how do we get QM? Now if you were to drop a perpendicular from the center to the point of tangency, then that same, so if I were to take this point of tangency as some W, okay, now if I were to move this OW along, then OW will be equal to QM, right? So OW is nothing but R, so obviously QM is going to be R. So if I were to extend this is how the triangle looks. As of now, this is the shape of the triangle. Okay, so this is Q, this is O, this is M. OM is already got, QM is there, and now all we need to do is to apply Pythagoras. OQ is also got, and then evaluate it. So that's exactly what we are going to do. So this is 90 degrees. So let me go to the next side and evaluate this. So by Pythagoras, so what do we have? By Pythagoras rule, so we have the following. So I'm going to take it as MQ squared plus OQ squared is equal to OM squared. So MQ is what? MQ is R. OQ, we have got OQ is R negative 20 over 3. The whole square is equal to OM. What is OM? OM is 52 over 3 negative R. Okay, 52 over 3 negative R the whole square. So we will have to solve this, okay, to get R. So let me solve this. R squared plus R squared negative 2 into 20 over 3 times R positive 20 over 3 the whole square is equal to 52 over 3 the whole square negative 2 times 52 over 3 times R plus R squared. So this is the system that we have got. So clearly R squared and R squared gets cancelled, and we have R squared negative 2 times 20 over 3 times R. I'm going to push this to the other end. So 2 times 52 over 3 of R and plus 20 over 3 the whole squared negative 52 over 3 the whole squared is equal to 0. Okay, so this is what we have got. So we will have to solve this. So what I would do is I will start with the simplification of these two quantities. Okay, so you have negative 2 times 20 over 3, positive 2 times 52 over 3. So I can take 2 over 3 out. So this is going to be negative 20, positive 52. So this is going to give me 32. Okay, so 2 times of 3 of 32, and that is the simplification for this part. Okay, so next we have to simplify this part. So that's going to be 20 squared over 3 squared negative 52 squared over 3 squared. So I can take 3 squared out, 1 over 3 squared out. So 20 squared is going to be 400, 52 squared. So probably we can multiply it off. 2 2s are 4, 5 2s are 10, 5 2s are 10, 1, 25, 26, 4, 0, 2, 7. So this is 2704. Okay. So 270. So from 2704, let me check one more time. 52 squared. Okay, from 2704 you take away 400, you get 2304 with a negative sign, of course, divided by 3 squared. So this is what we got. So if I were to go to the next side, and write in this value, okay, so it's going to be r squared positive 2 over 3 times 32, and then negative 23 over 4 divided by 3 squared is equal to 0. So we will have to solve this. Okay, of course there is a r here. So if I were to multiply by 3 squared, so this is going to be 3 squared, r squared, positive 2 times 3 times 32 times r, negative 2304 is equal to 0. So this is 9r squared, positive 6 multiplied with okay, so let me see if no, we cannot reduce it by 3. So 21 to 18, can we reduce this? So if 7 3s are 21, carry 2, 20 18. Okay, it seems that we can divide this quantity by 3. So this is what we have got. So I'm going to divide by 3. Okay, so if I divide by 3, this is going to be giving me 3 squared, 3r squared, 3 and 3 gets cancelled here, so it's going to be 2 times of 32 times r, and negative 6 3s are 3 divides here, 6 3s are 18, or not 18, 7 3s are 21, 22, 23, 20 times 6 3s are 18, 19, 20, 24, 8 3s are 24. So this is what we have got. 768 is equal to 0. So we cannot do anything else further. We will have to use quadratic to reduce this. So 3r squared plus 64r negative 768 is equal to 0. So r is equal to negative 64 plus or minus root of 64 squared negative 4 times 8 times 768 divided by 2 times of a. So 64 squared, I hope you can see that, 64 squared, that is 4096, 4 negative positive, so 768 multiplied by 12. So that's 9216, and negative 64 plus or minus divided by 6. So I add 4096. I get this. So square root of 13312 plus or minus negative 64 divided by 6. So I take the square root of this value. So square root of 13312. This is giving me 32 times root of 13. So let me take the evaluate it. So that's giving me 115.37. I'm going to take it to 115.4. So plus 115.4 negative 64 divided by 6. So I am taking away 64. Okay, 64 from it. 115.4, you take away 64. So this is what you're getting, and you divide by 6 and 8.56. So let me check one more time. 115.4 minus 64, you get this. You divide by 6, you get approximate value of 8.6 units. Okay, so what is this? This is the radii of the small circle. So the circle that we see here, okay, this is the radius of this circle, 8.6 units.